So today's first topic is called heat transfer, and it talks about the three methods in which heat is transferred from one place to another. So you've probably heard of these three methods before in science class in middle school or even in elementary school, but it's important that you have them fresh in your minds and that you relate them to all of the thermodynamics that we're going to learn this trimester. So the three methods of heat transfer are called conduction, convection, and radiation. So I'm going to write them down here, and I'm going to explain and give examples of each of them one by one. So there's conduction, convection, and radiation. So conduction talks about when objects are in contact with each other, or molecules are in contact with each other. And the way in which heat is transferred in these cases is because of molecular collisions. So for example, if you have a knife, I don't know how to, a knife. And you heat one end of it, so you give some heat to this end. Let's say this is fire. And you heat it up and it's hotter here and it's colder in the other end because the heat hasn't reached it yet. The way in which the heat is going to transfer from one end to the other is through molecular collisions. So remember, a higher temperature means that molecules are moving faster. So as they move faster, they collide more against each other, and those collisions make those molecules move faster, and that way they're going to reach the other end of the knife, making the other end also move faster. Of course, it's going to be a little bit colder here than here, but some of the heat is going to be transferred through molecular collisions. So the important things about conduction are that it requires molecular collisions. So it requires the two objects or the two ends of an object to be in contact. So objects in contact. In contact. Yeah, so another example of conduction could be if I touch this board, I'm going to give some of my heat from my hand to the board through conduction because I'm touching the board. So the molecules of my hand are touching the molecules of the board and therefore handing it some of the heat. So what affects how much conduction there is? Well, there are four things that affect it. So one thing is the difference in temperature. So we're going to call this delta T for change in temperature. The hotter one object is with respect to the other object, the faster the heat is going to transfer from one object to the other. The second thing is the area of contact. Area of contact. So I'm going to pass more heat if I put my whole hand than if I just put one finger, because there is more area passing the heat. Another one is the length through which the heat has to move. So in the knife example, the longer the knife, the farther away the cold end is, the longer it's going to take for it to heat up, because the molecules have to move and pass the heat from one to the other, and if it's farther away, it's going to take longer. And the other one is the material, finally. So for example, you have gone out to in a sunny day in the coast when it's really hot, and outside you can touch, for example, a metal railing and you'll get burned really quickly because metal transfers heat very fast. But if you touch, for example, a concrete wall, even though it may be at the same temperature as the metal railing, the wall will feel cool because it won't transfer the heat as fast as the metal railing. So that is called the heat conductivity of an object, and we know sort of because in our lives we have gotten burnt and not burnt with objects before. We know which objects have a greater heat conductivity. For example, rubber doesn't conduct heat very well, wood doesn't conduct heat very well, but all metals conduct heat very well. So you can get burnt or you can feel it cool if it transfers heat better. So that is conduction. The second way in which heat is transferred is through convection. So convection talks about only liquids and gases. Liquids and gases. And it happens when big groups of molecules of the liquid or the gas move around. So it's not about individual molecules anymore, it's about groups of molecules. So we're going to see an example of convection with gizmos in a second, but basically it's what happens when you heat up a pot on a stove. So let me see if I can draw a pot. So this is a pot, and you have the fire down below here. Maybe it's here. And there's water in the pot. So you're going to boil water. The heat is closer to the water on the bottom. So the water on the bottom is going to be warmer as it receives the heat than the water on top, which is colder. Right? So, but one thing that we need to remember about gases and liquids is that hotter means less dense. Less dense. And colder is more dense. So maybe you've seen in chemistry and you remember that when things are less dense, they float. And when things are more dense, they sink. So what's going to happen is that this warm water that is at the bottom, it will get less dense and it will go up. And the cold water is more dense than the warm water, so it will go down. So what's going to happen actually is that this is going to create sort of like a whirlpool, a movement of water in this direction. And that will make the hot water go up, the cold water goes down and gets hot, and when it gets hot, it goes up also. And this water, which is now colder, will go down again, and therefore the water will be moving around in a circle, and all of the water will heat up equally. Well, sort of equally, because of that movement of water. So that is convection. And it happens with liquids, like in this case, and it happens with gases, like in the case of air. So for example, on the beach, the sand is very hot in the middle of the day. So the air that is close to the sand is going to get warmer, which will make it less dense, which will make it go up, and the cold air that is on top is going to go down and create a movement of air. So that is why many times you feel breeze coming from the ocean, and the breeze is cold because it's the warm air coming up from the sand and the cold air coming down from the ocean and from above. So that is the second heat transfer method, which is convection. And now the third one is called radiation. So radiation, so this one was in solids, this one was in liquids and gases, and radiation doesn't require a medium. So no medium, it's the only one that can travel through a vacuum or vacío. Can travel through a vacuum. Can travel through vacuum. So what this means is that it's all of the radiation that comes from light and that we feel as heat on ourselves. So that includes, for example, the sun. The sun radiates and we can feel it all the way over here, even though it has to go through all of space, reach the earth and reach us. But we are going to feel that radiation on us. And the sun is not the only thing that radiates heat. Anything that is hotter than its environment radiates heat. So that includes also us. We are always radiating heat as long as we're hotter than the environment. So we're radiating heat, and that is why if you've ever been on a very packed bus, it feels hot and it starts feeling uncomfortably hot. And that's because every person inside the bus is radiating out heat and heating up the environment. So this also includes, for example, lamps. If you have a lamp in your house, of course. Let me see if I can draw a lamp. That's also going to radiate heat. And if you have a candle, that also radiates heat. So it's basically everything that doesn't require a medium to heat things up. So all of this, and actually everything, is always radiating heat and absorbing it. So we're always absorbing heat from anything that is warmer than us. And just the point of radiation is that it doesn't require any medium to travel by, and that is why light is the most common example of heat transferred by radiation. And also something that you can remember is that dark objects absorb more radiation, which is why if you're wearing a black shirt, you feel hotter than if you're wearing a white shirt, because that black shirt will absorb more of that radiation. Instead, mirrors don't absorb almost any radiation. So if you were to wear clothes made of mirrors, they would just, the light and the radiation would bounce back and it wouldn't heat up at all. So yeah, those are the three ways in which heat is transferred: conduction, convection, and radiation.